250 miles above our heads, hurtling through a vacuum at 17,500 miles per hour, sits the most expensive structure ever built. It is a $150 billion engineering marvel, the International Space Station. In an environment where humans weren't meant to survive, this tiny metal pin provides everything Earth does naturally: air, water, and protection. Today, we're uncovering the secrets of this superstructure and how it serves as our first stepping stone to the stars. You couldn't just blast the whole ISS into space at once. It weighs 460 tons, the equivalent of 300 cars. Instead, it was assembled piece by piece over 40 missions, involving modules from the US, Russia, Japan, and Europe. The project began as a political milestone in 1998, turning former Cold War rivals into collaborators. The first two modules, Russia's Zarya and America's Unity, faced an immediate crisis. Their docking systems didn't match. Engineers had to invent a Lego block connector, called the Pressurized Mating Adapter, PMA, to create a perfect, airtight seal in the vacuum of space. On Earth, air is a given. On the ISS, it's a manufactured product. Every astronaut needs nearly 2 pounds of oxygen daily. While oxygen tanks are delivered by rockets, the station's secret weapon is a machine the size of a trash can that creates air from water. Through electrolysis, electricity splits water into hydrogen and oxygen. But in zero-G, gas bubbles don't rise, they just sit there. Engineers solve this by spinning the mixture in a centrifuge, using mass and centrifugal force to separate the breathable oxygen from the liquid. Space isn't empty, it's filled with 500,000 pieces of debris, some traveling 5 miles per second. Even a tiny fleck of paint can hit with the force of a motorcycle at 60 miles per hour. To survive, the ISS wears a bulletproof vest called a Whipple shield. Rather than one thick plate, it uses multiple thin layers of aluminum and Kevlar. When a micrometeoroid hits the first layer, it pulverizes. The subsequent layers of ceramic fiber and aluminum catch the fragments, dispersing the energy before they can puncture the hull. How do you turn a football field-sized station without using precious fuel? The answer lies in the control moment gyroscopes, CMGs. Inside these casings, flywheels spin at 6,600 RPM. By tilting these spinning wheels, the station transfers angular momentum to itself, allowing it to reorient its position without using a single drop of propellant. Water is too heavy and expensive to ship constantly, $10,000 per pound. The ISS goal is 95% recycling efficiency. This includes yesterday's coffee becoming tomorrow's coffee. Through a sophisticated urine processing assembly, waste is treated with chemicals, distilled, and filtered until it is cleaner than bottled water on Earth. Temperature management is equally vital. In direct sunlight, the station hits 250 degrees Fahrenheit. In the shade, it drops to minus 250 degrees Fahrenheit. To prevent the station from becoming a deadly incinerator from internal electronics heat, engineers use a toxic ammonia cooling system. Unlike water, ammonia won't freeze in the external radiators, allowing it to dissipate heat into the void. The ISS has been continuously occupied for over 20 years. It isn't just a lab, it's a survival test for our species. From testing inflatable modules like Beam 40 to 41, to studying how the human body reacts to long-term spaceflight, everything learned here is preparing us for a 2.5-year mission to Mars. As we look up at that moving dot in the night sky, we aren't just looking at a satellite. We're looking at our future.